Hey you guys, welcome back. As you'll notice, I'm in a different location right now. They had to close a few classrooms down, so I had to go and find somewhere new to film the rest of the study guide. But that's okay. All right, so let's go ahead and finish with number 8. That's where we left off on the last video. So number 8 says, what's the difference between theoretical probability and experimental probability? So I'm going to abbreviate theoretical probability to TP. Theoretical probability is what you think should happen. It's what should happen. When you flip a coin, it has two sides, heads and tails. If you flip it 10 times, half those times should be heads, the other half should be tails. That's what should happen. But experimental probability, abbreviate that one as well, is what actually happens. So when you, actually finish writing this, is what actually happens when you collect data and do an experiment. So if I know that flipping a coin 10 times, half those times should land on heads, half should land on tails. If I actually go and flip the coin 10 times, that's probably not going to happen. I might land on heads 7 times and tails 3 times. Something like that. That's experimental probability. All right? So theoretical is what should happen. Experimental is what actually happens. Let's scroll down to this. Let me give that an erase. Let's go down to number 9. Number 9 says, please use, let me get the pen back. There we go. Number 9 says, please use the data in the chart to write the experimental probability as a simplified ratio and a percentage. So the first thing says number of total spins. It doesn't say that anywhere. We actually have to go and find that. Here are all my spins. I landed on green 6 times, blue 9 times, yellow 14 times, and orange 11 times. I'll add all of those numbers up, and I end up with 40 total spins. Now, let's go and find the probability of landing on green. So if I was looking at the theoretical probability, what should happen, 25% of the time I should land on green because 1 out of 4 of these sections is green. 1/4. That's my probability of landing on green. However, we actually did an experiment, and this is our data here. Let's see how many times we actually landed on green. We landed on it 6 times. So, according to the experiment, I landed on green 6 times out of 40. 6 out of 40. When I simplify that down, I get 3 out of 20. And 3 out of 20, at least in terms of a percent, is 15%. The next one, not yellow. Any color other than yellow. So let's look and see. I need that green. I need the blue. And I need the orange. Those are all my colors that aren't yellow. Let me go add all those up. 11 plus 9 is 20 plus 6 is 26. So 26 out of 40 times I landed on a color that wasn't yellow. I'm going to simplify that down to 13 over 20. That's a 3 right there. Then I'm going to turn that into a percentage, and that's going to give me, actually, let me grab my calculator. 1 second. 1 second. It's going to give me 65%. The next one, the probability of landing on orange or blue. Let me give that an erase so I can see it a little clearer. Orange or blue. So I landed on orange 11 times, blue 9 times. That's 20. 20 out of the 40 total spins, I got my favorable outcome, orange or blue. That'll simplify down to 1/2, which is 50%. Probability of getting a red one, looking at my colors, there's no red. So 0 out of 40 spins, I landed on red. 0 out of 40, that's 0%. Now, the next one, it says using the data in the chart from question 9, set up a proportion and answer the questions. If you were to spin the spinner 120 times, how many times would you land on orange? Not really sure why there's a little grammar line there because that seems grammatically correct to me. But on your study guide, I think it says red, but I told you guys to mark it out and just write orange. All right, so just mark out if it says red on yours and write orange. Now, let's go and write a proportion. Proportion is 2 fractions, or ratios, actually, set equal to each other. Now, it's always kind of confusing where the numbers go and where the x goes because I need 3 numbers and an x. So let's go and figure out where that stuff goes. Looking back up here in the chart, I know that I landed on orange because that's the color I'm talking about. I landed on orange 11 out of 40 times. That's going to be one of my proportions, 11 out of 40. The other side, I want to know how many times out of 120 spins. So it's really important to think, will my 120 be on the same shelf as 11? Or will it be on the 40, the same shelf as the 40? It's going to be down here with the 40. That's because all of these are total spins, like the total amount of times I spun it. Out of 11 out of 40 times, and how many out of 120 times? We don't know. That's where our x goes. That's our variable. Now, let's go and cross multiply and divide. I get 40x equals 11 times 120. Let me grab my calculator. Don't be a hero. Use the calculator. 1,320. Divide by 40 on both sides to get x by itself. And I'm left with x is equal to 33. So 33 out of 120 times I would land on orange, at least according to the data that I've already gotten. So if we give you a chart, use the chart. The next one, if you were to spin the spinner 200 times, how many times would you land on green? Same thing, let's set up a proportion. The number of spins, the total spins or total experiments, I'm going to keep that on the denominators, all right? So let's go and see how many times we spun this thing in the original experiment. How many times I landed on green? It looks like I landed on green 6 out of 40 times. That's going to be one of my ratios, 6 out of 40. And we want to know how many times I land on green if we spun it 200 times. 200 will be my other denominator. 40 and 200 are both the total amount of spins, so they're going to be on the same shelf. And then my numerator will be x. Let's go ahead and cross multiply. 40x equals 6 times 200, that's 1,200. Divide both sides by 40. And x is equal to 1,200 divided by 40 equals 30. So if I spun it 200 times, I would land on green 30 times, according to how the data is going so far. Let's actually scroll down and give that an erase. Oh my gosh, there we go. Let's scroll down so we can do the next part. Number 11. So this one says that 10B rolls a fair six-sided number cube 50 times. She rolled an even number 35 times. What's the experimental probability of rolling an even number? If we're talking about experimental probability, we're going to use the data we actually collected. She rolled this number cube 50 times. That number of times, the number of experiments, that's our denominator. How many times did she roll an even number out of 50? Looks like she rolled it 35 times out of 50. So I'm going to have 35 out of 50. When I simplify that down, it's going to give me 7 out of 10. When I turn that into a percentage, that's going to be 70%. Now it says, what's the theoretical probability of rolling an even number? Theoretical, I'm not really considering how many times I landed on what when I rolled it. I just want to go and see how many times I should land on an even number. So when I go and do that, and I actually figure out how many times I should land on it, out of a six-sided number cube, 3 of those numbers are even, 2, 4, and 6. So 3 of those numbers out of 6 should be an even number, which is 1/2. Or if you wanted to start up here, 25 out of 50 of those rolls should be even numbers. Or 3 out of 6, which all of it reduces down to 1/2, and that's going to be 50%. What could you do to make the experimental probability more closely match the theoretical probability? So the theoretical is 50%. Half of those rolls, she should land on an even number. But when she actually went and rolled it, 70% of the time she landed on an even number. So she had way more even numbers than she should have. How do we make these closer together? All we could do is roll the dice more times. Or in other words, do more experiments. Roll the dice more times. We only rolled it 50. If we rolled it 500, these two probabilities would be closer together. If we rolled it 500,000, these two probabilities would be closer together. If we rolled it 5 million, these would gradually get closer and closer together. All right, the more experiments we have, the closer the theoretical will be to the experimental. What's the difference between a population and a sample? A population is everyone involved. Or I should say everyone in the study. So a lot of hours talking about finding how many kids at DeSana like certain things. If we were going to go and actually ask every single kid at DeSana, that would take forever. There's 1,500. So population is everyone. However, we're going to find the sample, which is part of the population. A sample is just part of the population. So if I was going to ask everyone at DeSana how much or how many movies they watched last month. That would take forever to ask every single kid. Instead, I would just go and ask a small sample of that population, and that would give me a good idea of how many kids at DeSanta, or how many movies all the kids at DeSanta actually watched last month. The next one, how can you tell if a sample is biased or random? So random is anyone has a chance to get picked. Random means everyone or anyone can get picked. And random, at least in terms of collecting data, is fair. It's a fair way to do it. Biased, however, is unfair in some way. In some way, because only certain people get picked. Only certain people are picked. So let's go down here and look at one of these. Identify the population and the sample. Then determine if that sample is biased or random. Armani wants to find out how many kids at DeSanta like golf. She asks 20 students in the golf club. If she wants to know how many kids at our entire school like golf, and she only asks the kids in the golf club, I can guarantee every single one of those kids in the golf club is going to say they do like golf. So that is not a good sample to ask because it's biased. All of them are going to give the same answer. So the population here is all kids at DeSanta. She wants to know about every single kid at DeSanta, but she can't actually ask every single one. That would take too long. So instead, she's going to ask a small sample. And in this example, at least, she asks the 20 kids in golf club. So that's her sample, 20 kids in golf club. It is biased because she's going to find out that all the kids like golf club that are in golf club. So that's not really a good representation of all the kids at DeSanta. Let's go and do the next one. Let's scroll down. Let me give that an erase. Wrong one. There we go. The next one. The next one says, Arden wants to know how many kids at DeSanta walk to school. He asks every 5th kid he sees in the gym. So the population is all kids at DeSanta. All kids at DeSanta, because that's who he wants to find out about. He can't ask every single one of them, so he's going to ask a small sample. And he's going to ask every 5th kid he sees in the gym. So the sample is every 5th kid in the gym. And it doesn't say biased or random here, but this would be random. He asks every 5th kid that he sees. It could be anybody. There's no real rhyme or reason to who he's asking. It could be anybody in the gym, all right? The next one, how do you determine the mean, median, mode, and range? The mean, that's like the average. That's where we add up all the numbers, then divide by how many we have. Then divide by how many numbers there are. The median, that's where we order from least to greatest. Order least to greatest, and you do have to do that. Okay, that's the important first step. Then find the middle number. So the median is just the number right in the middle. The mode, that's just the number that appears the most. It's the number that appears the most. And finally, I'm going to underline most. And finally, the range. That's where we take our biggest number, and I'm going to use the word maximum, and subtract it, subtracting symbol, the minimum, the smallest number. So your biggest number, maximum, minus the smallest number, the minimum, and that'll give you the range. Now, I'm going to call it at that video, and I will pick up with you guys on verse 16 in the next one.